We're about to uncover a secret that's literally right under your boots, one that most people never even realize is there. We're talking about a hidden kind of gold deposit, Supergene Gold. This isn't the kind of gold you see sparkling in riverbeds or wedged in quartz veins. Instead, it's gold that's been moved and concentrated by nature's own processes, often hiding in plain sight. Unlike those flashy quartz veins that catch everyone's eye, Supergene Gold forms quietly, right under your feet, thanks to the slow but steady work of rainwater, air, and the relentless passage of time. Over years, even centuries, these forces break down rocks and move minerals around, creating new opportunities for gold to accumulate. Most people walk right over these zones, missing the treasure because they don't know the signs. It's easy to overlook what you can't see, especially when the ground looks barren or unremarkable. But here's the magic. Nature does the hard work for us. Weathering breaks down rocks, rainwater dissolves minerals, and gold gets leached from the surface, then carried and concentrated deeper down. Over time, this creates a hidden layer of riches that's just waiting to be discovered. The result? A layered ground profile, almost like a cake, where the real riches are just below a tough, barren-looking top. If you know what to look for, you can spot the subtle changes in soil color and texture that hint at gold below. Many give up after digging a shallow hole, not realizing the gold is just a bit deeper. It's a classic mistake, one that's cost countless prospectors their fortunes. Learning to read these layers, to interpret the clues left by nature, is what separates amateurs from real prospectors. It's about patience, observation, and a willingness to dig just a little deeper, both literally and figuratively. Stick with me as we break down the process, learn to spot the clues, and use both old-school field smarts and modern technology to find these hidden hotspots. With the right knowledge, you can turn overlooked ground into a gold mine. By the end, you'll see rusty ground as a signpost, not worthless dirt. Let's get started and unlock the secrets beneath your boots. Let's dig into how supergene enrichment works, a fascinating natural process that transforms ordinary rocks into rich gold deposits over immense spans of time. It all begins with a primary gold ore body, often found as a hard rock vein deep underground, packed with minerals like pyrite, also known as fool's gold. These veins are the original source of gold, locked tightly within the rock. Over millions of years, natural forces like wind, rain, and temperature changes slowly erode the landscape, bringing these gold-bearing veins closer to the surface. This exposure is crucial as it allows surface processes to begin. Rainwater, now loaded with oxygen from the atmosphere, seeps down through cracks and pores in the rock. As it moves, it reacts with sulfide minerals, especially pyrite, triggering a chemical reaction called oxidation. This oxidation process creates sulfuric acid, turning the water acidic. Acidic water is powerful. It can dissolve a variety of metals, including gold, which is usually very resistant to change. Under these harsh, acidic conditions, even stubborn gold can dissolve. The gold-laden water then percolates downward, carried by groundwater through fractures and spaces in the rock. As this happens, the upper part of the ore body is stripped of its metals, leaving behind a pale, depleted shell, a zone that's been leached of its valuable elements. This entire process unfolds over thousands, even millions of years. The water table, the level below which the ground is saturated with water, acts as a key boundary in this story. Above the water table, leaching dominates, stripping metals from the rock. But below the water table, the chemistry changes dramatically, setting the stage for something special. Here, the lack of oxygen and different chemical conditions cause the dissolved gold to stop moving and settle out of the water, forming concentrated gold-rich zones at depth. Remember, this is a slow, relentless process. Nature's patient hand at work, shaping the landscape and concentrating gold over eons. The real action happens right at the boundary where the chemistry flips, from oxidizing to reducing conditions, creating a sharp line in the rock. That's where the gold piles up, forming the rich deposits that miners seek, nature's hidden treasure, patiently gathered over countless generations. Here's the chemistry, made simple. Pyrite reacts with water and oxygen, creating iron oxides, rust, and sulfuric acid. This acid lowers the pH, making groundwater corrosive. Acidic water attacks minerals, breaking rock into soft clays, easier to dig. Gold won't dissolve easily, but in acidic, oxidizing conditions with chlorides it forms a soluble gold-chloride complex. Gold now travels downward in solution. The journey ends at the water table, where conditions turn reducing. The gold complex breaks down and gold drops out of solution, becoming solid again. This isn't random. Gold precipitates where there's a chemical trigger like a pH change or certain minerals. Over millennia, gold accumulates in this zone. That's how a low-grade deposit becomes a rich secondary one. This is the enrichment blanket. It's nature's way of concentrating gold. Let's talk about what you'll see in the field, and why it matters for anyone searching for hidden mineral wealth. The very top layer you'll encounter is called the Gossan, or oxidized cap. It's hard to miss. Look for those striking reds, oranges, yellows, and browns that seem to glow in the sunlight. These colors are nature's way of waving a flag, telling you something interesting happened here. These vivid stains are your first clue. They're the result of the breakdown of pyrite and other iron minerals, which have been exposed to air and water over thousands, even millions of years. The iron reacts and leaves behind these colorful marks. The Gossan is what's left after acid and water have leached away the gold and other easily dissolved minerals. What remains is a weathered iron-rich cap, almost like a protective crust on top of the original ore body. It's mostly iron oxides. Think of it as the rusty skeleton of the original ore. Hematite and goethite are common here, giving the rock its distinctive rusty look and rough texture. While the Gossan is usually barren of gold itself, it's a valuable indicator for prospectors and geologists. It marks the spot where mineralization once occurred, acting as a beacon for further exploration. Look closely for boxwork textures. These honeycomb-like patterns hint at a sulfide-rich source below. They're the ghostly remains of minerals that have long since dissolved away. Train your eyes to spot these color patches. Sometimes they're just a few rocks, other times they stretch across entire hillsides, painting the landscape with rusty hues. Don't expect your metal detector to beep here. The gold is long gone, carried away by water and time. But don't be discouraged, this is still a vital clue. Think of the Gossan as the map, not the treasure itself. It points you in the right direction, guiding you to where the real prize might be hidden deeper underground. The richness and variety of color can give you hints about what's below. Sometimes, the deeper the red, the more iron-rich the source. Become a student of rust. Deep reds usually mean lots of iron, while lighter yellows might suggest other minerals or different conditions during formation. So, when you find a Gossan, you've found the front door to the treasure. It's the starting point for every great mineral discovery, an invitation to dig deeper and uncover what lies beneath. Dig past the Gossan and you'll hit the Leech Zone, a pale, ghostly white or tan layer. It's soft, crumbly, and made of altered rock and clays left after intense leaching. This is where many prospectors give up, finding no gold and assuming it's a dud. But this empty zone is proof the supergene process worked. It means gold was dissolved and moved downward. Pay attention to the texture, lightweight, porous, sometimes with quartz fragments. The thickness of this zone tells you how much metal was mobilized. Don't sample here for gold, measure and note its character. A thick, intensely leached zone means more gold likely moved below. Hitting white isn't failure, it's confirmation you're on the right track. You've identified the top two layers, the rusty hat and the empty middle. The gold had to go somewhere, down. Your next target is the bottom of this pale zone. Now for the payoff. Below the leached zone, the material gets darker and heavier. You've hit the supergene enrichment blanket. This is the pay zone where gold from above is redeposited and concentrated. Colors range from dark browns to blacks, sometimes greenish or bluish if copper's present. The key is density. The dirt feels heavier. This layer forms at the old water table, where oxidizing and reducing conditions meet. You'll find secondary minerals in fine, pure gold, often flour-like but rich. Signs you've hit it: color change, increased weight, and your metal detector finally comes alive. Start panning carefully. The gold is fine and easy to lose. The blanket isn't always flat. Follow its contours and dig multiple test pits to find the richest spots. Don't stop at the first sign, explore its size and shape. Systematic work pays off. You've read the layers and reached the treasure. This is where patience is rewarded. Old prospectors relied on grit and luck, but today we have powerful tools. Start with geological maps. Find areas with primary gold and sulfide minerals. Remote sensing and satellite imagery can spot iron oxides and clays from space, revealing hidden Gossans and leach zones. AI can analyze this data, flagging likely supergene systems across vast areas. Geophysical surveys like induced polarization and magnetics help map what's below the surface. Combine all this data to build a 3D model and pick the best spots to dig. But remember, tech only points you to the X. You still need boots on the ground. The real confirmation comes from digging, panning, and reading the rocks. Use modern science to find targets, then old-school skills to verify and strike gold. The best prospectors blend both worlds. That's how you find the real pay dirt. Let's wrap it up. Nature creates a 3-layer gold profile rusty Gossan on top, pale Leech Zone in the middle, and a rich enrichment blanket below. Each layer tells part of the story. You need to read them all. The biggest mistake? Stopping in the Leech Zone. If you see the Gossan and the pale layer, trust the process and keep digging. The absence of gold in the middle is a good sign. It means gold moved down. Train your eyes for color and texture changes. Trust what you see. The rocks don't lie. Don't quit just above the gold. Have patience and persistence. Supergene gold deposits have made fortunes and are still out there, often overlooked. Now you know how to spot them. Pay attention to the layers, dig deeper, and trust your knowledge. The real gold is just beneath where most people stop. Good luck, and see you in the field.